All right, so we're going to be talking about two theorems today. We're going to be talking about the remainder theorem and the factor theorem. So the remainder theorem basically says that if I have any polynomial, let's call it f of x, and it is divided by a linear binomial, x minus k. Remember, k is that number, like when we did synthetic division, that would represents a potential root or zero or solution. It says that the remainder that you get is going to be the same thing as if you took k and you plug k into the problem. So basically, if I substitute k into my whole polynomial, then that will result in the remainder. Okay? So when a polynomial f of x is divided by x minus k, the remainder is the same thing as if I substitute k in and it gives me out that value. That is the resulting remainder. So a few examples of that would be, so let's say that I have, this is my polynomial. I have 2x cubed plus 3x squared minus 17x minus 30. All right, so when I'm looking at A, I have x minus 1. So with x minus 1, we should be able to identify that my k value for this particular problem is x equals positive 1. So this says if I take 1 and I plug it into my polynomial, whatever number I get out, that resulting number, that would be my remainder if I had done long division or synthetic division. Okay, so for this particular problem, I'm going to take, I have 2, where every x is, I'm going to replace it with 1, plus 3 times placeholder squared minus 17 placeholder minus 30. Okay. All right, so in those placeholders, I'm going to put in my k value. So I have 1, 1, and 1. And I'm actually going to calculate that. You can pull up Desmos and calculate it however you want to do it. And when I calculate that value, I should get negative 42. So all of this being said, if I plug f of 1 in and I get out negative 42, is my remainder. So right here for negative 42, that is my remainder if I were to have done long division or synthetic division. Okay, so this process works out the same way regardless of which example you're doing. So let's say I do x plus 2. So with x plus 2, my k value this time is going to be negative 2 because it's the opposite if we were to actually solve it. So that means that I'm going to try to figure out what f of negative 2 is. All right, so we're going to take negative 2 and we're going to put placeholders for every x value. And in those x placeholders, we're going to put in negative 2. Now, if you calculate this, you should get that f of 2 has a remainder of 0. And that's going to be super important come our next section. And I've talked about it before, that when we were doing the long division and the synthetic division, that remainder of 0 is going to be significant. All right, so in just a second, I want you to pause this video. I actually want you to do C and D. So I want you to determine what your k value is and then plug that into your polynomial and figure out what your remainder is going to be. And then once you're done, unpause it and then check your answer. All right, so for C, you should have gotten that k is negative 3. And if you plug in negative 3 for each of your values, then you should have gotten that f of negative 3 is equal to negative 6. So the remainder this time for this one is going to be negative 6. Again, you could do synthetic division or you could have done long division, but this is just a shorter process when we actually need to use the information behind it later. All right, so then for this one we have k equals positive 3, and for k equals positive 3, so f of 3 is going to have a remainder of 0. Again, these are very important when they have a remainder of 0, but what you need to know about the remainder theorem says that if I take whatever my k value is and I plug it into my function, it is going to result in the remainder. Okay, that is the biggest thing that you need to remember. Now, what we're going to do in the next section is we're actually going to talk about Well, why do we need to do this? What does it mean when my remainder is equal to 0? Well, that comes to the point where we talk about the factor theorem. So the factor theorem says that if I have a k value and I substitute that k value in and it results in a 0, then that whole polynomial x minus k is a factor of that polynomial. So remember, we learned how to factor and we learned how to break down a polynomial into smaller pieces that have been multiplied together. What I'm saying is if I plug in my k value and that k value equals 0, then that piece is one of the factors of that polynomial. That also means that the k value itself, so that k value is a 0, an x-intercept, a root, or a solution of the polynomial. So what does that mean? That means that it's where it crosses the x-axis. It's a solution, okay? So we're going to go back and we're going to say, using the problem from the remainder theorem, which of the given binomials are factors? So in just a second, I want you to pause the video and I want you to go back and look at the remainder theorem, and out of the 4 problems we did, decide which ones had a remainder of 0. All right, so if you go back, you should have seen that the 2 that had a remainder of 0 were x minus 3. And the other one was x plus 2. So those 2 linear binomials, so x minus 3 and x plus 2, are factors of that polynomial. That also means that x equals 3 and x equals negative 2 are x-intercepts, zeros, roots, solutions, whatever you want to call it. If you graph it in Desmos, you should be able to see that it crosses the x-axis at 3 and negative 2. So what I want to do now is I'm actually going to do some synthetic division, and we're going to factor this entire polynomial. And we're going to factor it using these 2 remainders. Sorry, not remainders. We're going to factor in using these 2 polynomials that we figured out were factors through the remainder theorem. So I'm going to start with the first one. So the first one was x minus 3. So my k value is x equals positive 3. And my problem was 2, 3, negative 17, negative 30. Okay, so I'm going to bring that down. So that's going to give me 6, 9, it's 27. Negative 17 and 27 is going to give me 10. 3 times 10 is going to give me 30. When I add those, my remainder is 0. That should happen because we've already determined that it was a factor of the polynomial. If it's a factor of the polynomial, it should have a remainder of 0. So now we're actually going to do synthetic again. So we're going to do like a double synthetic problem. So the other k value from the x plus 2 is going to be x minus 2. So I'm going to do the process again with my new pieces, my new coefficients, after I've already done the division from x equals 3. So that should be equal to negative 2. So bring down the 2. Negative 2 times 2 is going to give me negative 4. That's going to give me 5. And then negative 2 times 5 is going to give me negative 10, remainder of 0, which again should happen. So at this point, what do I know? I know that I have x minus 3 is a factor and x plus 2 is a factor. So what is the rest of my problem? Well, the rest of my problem is going to come from this 2 and this 5. So if we put it back together, now we got to think. So we started out as x cubed, then we dropped it down to x squared, and now we're dropping it down to x. So when I put it all back together, I should have 2x plus 5. Well, 2x plus 5 is my remaining factor. If you go into Desmos right now and you graph this original polynomial, and then you graph those pieces together, they are going to produce the same graph. We just factored using the remainder theorem to figure out what some of the factors were, and we did the factor theorem to reduce it down. So now we're just going to do some basic practice. So the next problem says, is x plus 1 a factor of this polynomial? So how do I know if it's a factor or not? Well, to know if it's a factor or not, I can do my synthetic division, I could do long division, or I could do my remainder theorem to figure out if it's a factor. Remember, if it's a factor, then my k value for this problem is going to be negative 1, and this says that if I plug in -1, in order to be a factor, it has to equal 0. So we're going to test that out. So we're going to put parentheses, placeholders cubed, minus 9 placeholders squared, plus 15 placeholder, plus 25. All right, and in those placeholders, we're going to put in -1. All right, and if this comes out to be equal to 0, then we have found a factor of this theorem. If it doesn't come out to equal 0, then it's not a factor. It's just that simple. Now, this does come out to equal 0, so the answer to this is yes, x plus 1 is a factor. Okay? So pause this video and do the same thing for the next one, and then come back and check. All right, so my k value for this one is going to be +2. And so that it's asking if I plug in 2, does this equal 0? So that's the big old question mark. Does that equal 0? All right, so placeholders again. And if I put it's the same problem. So cubed minus 9. And I can put in, for this one, we're putting in 2. And I got that f of 2 is actually equal to 27. So if f of 2 is equal to 27, that means that this is not a factor. All right, if you need any extra help, remember I have office hours from 2 to 3 and on the Zoom link, and I have it on Thursdays from 6 to 7.